Yeah, as Juliana said, I'm Daniel. I'm from Graz. So this is our first cloud native Linz Graz mashup event. I think we actually did a better job with our logo. So we also have stickers, as Juliana said. Please pick up some stickers. I ordered 200 pieces and I underestimated how many 200 actually are. I tried to get rid of them at KubeCon, didn't work out. So yeah, I'm Daniel. I'm a senior DevOps engineer at FullStacks. We're an Austrian company. I'm also the community organizer of CNCF in Graz. And since last year, I'm also one of the core organizer team members of KCD Austria, which I'm going to talk to you about after the actual demonstration. So please bear with me. If I should forget to switch back to the slides, please remind me, since that's important. I'm also one of the organizers, Vorstände, whatever, of Cloud Native Austria, which is kind of an association, a Verein, that is responsible for the legal side of organizing bigger community events in Austria. So since last year, we had KCD Austria with 300 plus people, and you need to have a legal entity for that in Austria. Last year, Dynatrace did that for us. This year, the community is doing it ourselves. And for that, we founded Cloud Native Austria, and we also have a great logo for that. And we also have stickers. 200 of them, so please also grab some Cloud Native Austria stickers. Yeah, if you need to or you want to stay in touch with me, Drack is my handle pretty much everywhere. You will find me on the internet. Yeah, and I'm going to talk about security today. Who of you is a security person? Raise your hand. Okay, I need to be careful what I say. Since security is kind of a multi-layer topic, and there are so many facets to that and so many sides to that, we at FullStacks, we try to come up with an easy idea, an easy model, as easy as it can get, to kind of put all the dimensions of security and infrastructure and application security, etc., into a graspable model. And what we came up with are two verticals. We have a vertical dimension and we have a horizontal dimension. Vertical basically means infrastructure stack from bare metal, so really access to the data center, yada, yada, up to the publishing layer, firewalls, stuff like that, web application firewalls and stuff like that. And in between somewhere, we have network, storage, compute platforms, support systems, and the application. And the horizontal dimension is actually how you create an application. Some might call it supply chain security. That's the gist of it. And I'm going to show you a product today, open source product, very important, that can cope with at least some of these layers. So as I said, security is a multi-layer thing. If you put all your eggs into one bucket, you're definitely going to be screwed. So try to approach it from different levels, use different tools, multiple layers, and don't try to stick to one solution. But NeuVector is one thing that can actually help you at least cope with some of these layers. If we talk about container security from the horizontal point of view, first what we have is we have the build step. So once you would check in code, you would do some things like SCA, software composition analysis, dependency scanning, static code application scanning, stuff like that. And once that's done, you have a build, you have a container. You also want to scan your container. Containers bring additional resources, additional software packages, etc. So not only your application, but also dependencies. You want to scan for that. But you don't only want to scan during the build. You also want to scan the registry regularly, since somebody could alter the images, for example. Never use the latest tag, by the way. Once that's done, you also want to check your infrastructure, your cluster. Maybe not for CVEs, but for misconfiguration, compliance stuff. So all these CIS benchmarks, if you're familiar with that. Then you also want to check against compliance regulations. So not only best practices, but real hard regulations. HIPAA, NIST, stuff like that, especially if you're operating in a highly regulated environment, banks or hospitals, stuff like that. And as you go into production and you start to run your applications, you also want to have some kind of runtime security in place. So scanning at the build level is not enough. You also need to continually watch your application. And on top of all of that, you continually want to have some kind of risk reporting remediation. So you also want to have a big overview and not only see the vulnerabilities, but also assess the risk that come with all these security vulnerabilities. And that's something NeuVector can, at least to some extent, help you with. So in a nutshell, NeuVector, I'm pretty sure everybody knows this typical cloud native architecture. You have something like the brain or the master or the control plane stuff, and then you have some worker stuff. NeuVector works pretty much the same. You have a UI thingy, you have a controller thingy, and then you have an enforcer, which is pretty much the scanning scanning side of things. And what NeuVector can actually do for you is it can operate on these two levels. You have runtime security and you have supply chain security. Supply chain is all the horizontal layer we talked about before. So when you build the application, when you check for compliance, and when you run the application on the runtime side, you have this real-time live monitoring stuff. Monitoring your networks, monitoring file access, monitoring processes, web application firewall, data loss prevention, all that stuff that's going on once the application is actually deployed. And NeuVector can help you with both of that. I shouldn't say that, but probably NeuVector is not the only tool that can do that. It's quite good, but there are other tools that do certain things better. So as I said before, try not to use to depend on one single tool, but try to use a multitude of tools, useful tools. And I'm going to show you in a minute why. If we have a somewhat typical cloud-native application development cycle, as I said before, what you would do is you would start with some kind of build, application build and container build later on. And that's the first thing that you could then do with NeuVector. You could scan the result, at least the container, with that thing. You would then push this somewhere to a registry, to a repository. According to maturity levels, you would move it from some kind of sandbox repository to a test to a production repository. And hopefully you would also scan these again and again, since, as I said, you could hypothetically also alter these images afterwards. So you also want to continually scan your registry, at least when there are updates. That's also something NeuVector can do. Once the thing is deployed, you can do some kind of runtime security and runtime scanning. That's something I'm going to show you in the demo. You can do benchmark checks, which are not actually kind of security or CVE checks, but more like checks for known misconfigurations. SUSE, for example, provides hardening guides and best practice guides, let's put it like that, called benchmarks for several systems and applications. For example, there's a SUSE benchmark for several Linux distributions, for Kubernetes itself, for dedicated Kubernetes distributions, but also for applications like Nginx, Apache, or something like that. So you might want to check if you're on the best practice side of configuration. That's something that NeuVector can also do. It will also print you a nice looking report from these compliance checks, which in some environments actually is quite important that you have some kind of proof. And of course, you also want to do all of these checks, security scans, etc., as some kind of policy. So not all scans, not all not all these scans and not all violations actually matter to each and every application. So basically, you want to have some kind of policy in place that actually says, hey, for this application or for this system, we need to be more careful. We need to have a higher, for example, CVE threshold that's acceptable or lower threshold. And that's what you typically would have in a policy. And of course, you want to have a policy as code. So we don't want to click anymore, we want to code. That's what NeuVector can do. So you can pretty much do everything via API. Since NeuVector's been around quite some time, at least several years before they got bought by SUSE. They actually open sourced it 3 years ago. So it's not open sourced that long. And they only had an API, and SUSE built this Kubernetes manifest configuration thing on top. So you can actually do policy and security as code. I'm going to show you in a minute what you can do with NeuVector. Okay. And you can configure everything that you can do in the UI also via the API and via YAML files and via Kubernetes manifests. I'm pretty certain you cannot read this, so I don't. Okay, so it doesn't make sense if I explain it right now. Yeah, but at the end of the day, security is code. It's important because you can have your policies with the application. I'm going to show you that in a minute. You can also have NeuVector specific RBAC. one more or less important thing is that it does not use the default Kubernetes RBAC. There are some dedicated NeuVector RBAC resources, but they can also be configured as YAML, so whatever. And you always have all the securities and the policies as code with your application, or as we heard before, you can also have them in kind of like an infrastructure repository for when you deploy NeuVector itself. So the overall configuration is a dedicated repository, also with Terraform. And the application policies strictly fit for that application. You put with your application code, for example, in a Helm chart. Okay, I hope my demo works. Who of you has heard about Log4Shell? Log4j? Awesome. Okay. Who of you was on duty when this CVE came out? Okay. I remember it was a Saturday since it was my on-duty time, and I did on duty for a whole week at a big Austrian automotive company. We had to check about 2,000 VMs and validate that no, we are not public, no, we're not using Java, and no, this is not the right Log4j version. If so, fix it. Does anybody know how you actually fix the Log4j incident? You delete the class file in the jar file. Okay. In a nutshell, Log4j works something like that. You have an application that uses Log4j, which is a Java logging library in a certain version. And this logging version has the feature that you can do some kind of lookups, and you can also you can use JNDI to do, for example, an LW lookup. So if you try to log a line and you have a certain interpolation lookup string, then Log4j in this version will just execute and interpolate this command inside there and execute the code that gets returned. So for example, if I'm the hacker, and I'm going to show you that in a minute, I send a request and in some header I have a JNDI lookup command. Then my application will just take this thing, say, hey, okay, this is JNDI lookup. I need to get something from LLab server out there, download the thingy, and if that's a class file, execute it. Not so cool. It's actually one of the first 10 out of 10 CVEs ever, because it's easy to use, it's highly spread. So Log4j is the most widely used log library in the world, and it's easily exploitable even by script kiddies. Then you could do things like data extraction, reverse shells, you name it. But it's also somewhat easy to detect. I'm going to show you. Because you have these certain lookup strings that you can look for with deep inspection in the packages that come in. Now, with NeuVector, we would potentially have more or less 3 options how we could remediate this threat right out of the way. First thing is image scanning. If I know that I have an image that is actually using Log4j, I can just turn off the container. Once I know that there is a CVE out there. That's what most of the companies tried to did in these first few hours. Try to come up with an inventory, see where you actually use Log4j, and then just get rid of the application. Switch it off, network off, or just delete the class file in the Log4j jar or whatever. But you need to know if you're using this thing. And for that, Log4j could help you by scanning the image. If you know that there is a threat already, so if it's not a zero-day vulnerability, but a known threat, you could also do some kind of an admission control. So I could say, hey, Kubernetes, if somebody wants to start a pod that's containing a container with a CVSS core greater 8, for example, just don't start this pod at all. You could do that with NeuVector, it's quite easy, and it's quite powerful. But as we all know, if there's a new feature upcoming and we have this one critical CVE and it's blocking deployment, there's always a way to ignore that. The next thing we could do is we could have some runtime security policies in place that, for example, limit the amount of network traffic a certain container or pod can actually use. So for example, I could just restrict the network connection from a pod to the internet. So if I have a data extraction attack, I can just block all outgoing traffic from my pod to outside of the cluster, for example. I could also have some file and process policies in place. That, for example, if the attacker wants to write a file, I'm not allowing that. If he wants to spawn a reverse shell, I'm just blocking any new upcoming processes. So these are multiple techniques I can use. Best all of them, as I said, don't just use one mechanism, use multiple, that I could employ to remediate this threat. And the last thing that we're also going to see now is web application fault data loss prevention, which is actually a layer 7 deep inspection thingy, where I actually look for these malicious a JNDI lookup header, and I don't deliver the packet to the container. Or the other way around, if I have data loss prevention, I see, hey, something wants to go out that shouldn't go out, for example, credit card number, I can also block the request going out. And just for the sake of completeness, you could also have compliance, custom compliance checks. NeuVector also supports that, but that's crap. Okay, this is more for me than for you, since I need to know what I need to show you. So the first thing we have here, that's our full stack lab environment. It's not Kubernetes, it's Rancher, same but different. I have this one pod deployed, which is basically just a simple Java Spring Boot application with a vulnerable version of log4j. If I send some requests there, it will log it out for me. And I have NeuVector running there, which is also integrated, and I'm pretty certain that my session will crash. One of the first things you get to know if you ever look into NeuVector, this thing happens a lot. Okay. So that's the UI of NeuVector. For example, we have this beautiful network activity graph. Load a bit. That's going on in my cluster. I'm not going to give you a full introduction into NeuVector, since this would, out of experience, take about 2 hours. But the gist of it is, I have NeuVector running on the cluster that you've seen before. There we have the vulnerable application. On my notebook, I started this evil LDAP server that is actually taking this JNDI LDAP requests from the vulnerable application and delivers something back. This thing pretty much just takes a command, wraps it in a Java class, and responds it to the application. The application is going to execute it and do what I tell them to do, more or less in a nutshell. And it works like that. Good. Can you see it? Thumbs up, thumbs up. Nice. Okay, that's actually a curl to the log4j ingress on my cluster, and I'm just adding this malicious header I mentioned before, and there we have this JNDI lookup thingy. So what log4j does is it sees that there is a header coming in. The application is actually configured to lock the headers, and since it sees this lookup, what's it called? Lookup quote. It will try to connect to this LDAP server, which is running on my notebook, and it will get this Java class in response and will execute the code inside. And the code pretty much does the code pretty much blue and black. I'm going to send the credit card number to my notebook. So data extraction use case. So that's what I'm going to do now. I'm going to hit this thing. Okay, we got a response from our application. So hello, attacker. In the application itself, the only thing we see. Okay, disconnected. Nice. So at least it logs out the log line. But the interesting part is here in NeuVector, we should now see a security event. That's enough. Yeah. We see an incident that is the web application firewall sensor. That's the incoming side that actually notices that I have this JNDI header in my HTTP request. So this would alert me, and I can also set that to protect, to block this request straight away. And the DLP sensor is the outgoing thing that actually detects that I'm going to send an American Express credit card number somewhere to the outside world. I could also block that, and that's what I'm going to show you now. So in NeuVector, we're always talking about groups. Since this product is also so old, they used to deal with Docker Compose, with Kubernetes, with OpenShift, so they had it all, and they need to come up with some universal term for workloads, but not only workloads, but also other things, so everything's a group. And the group can be everything: IP address range, container range, you name it. So what do you see here? That's actually a group for my container. So you can see it's actually a service selector at the end of the day, which selects each pod and each container by Kubernetes service. And it's in monitor mode. Monitor mode means that I get alerts, but it doesn't block anything. And if you look down here, zoom in is crazy. That's what I mentioned when I said custom policy checks are crap, because that's the UI you get. So there you can add your single line check script. It works, but not well. But the cool thing is, for example, here we have process profile rules. These are all the processes that are allowed in the container. If an attacker, for example, wants to spawn a shell, a reverse shell, then NeuVector would prevent the process from starting. Same applies to file access rules. In that particular case, we don't have any. But the idea is the same. And we also have network rules. In that case, it's pretty straightforward. The interesting part for us, I'm going to discuss in a minute, is this NeuVector to external HTTP any. So it's actually allowed to talk to the outside world. And what's also quite cool is this policy is learned. So NeuVector has a discovery mode, which just learns. If I deploy an application, I run some end-to-end tests, it will learn where and how the application communicates, which processes are started, which files are used. And once I'm done testing and the policy is learned, I can export it, add it to my Git repository or to my source code management system, and deploy it as a CRD in protect mode. So I don't have to come up with it from scratch. I can see what my application is doing, refine it a little bit, and then just check it into my Git. So what I'm going to do now is I'm going to switch to protect mode. It takes some seconds. All right. And here we also see this data loss prevention and web application firewall sensors. They are currently set to alert. So by now, still works since nothing is enforced. But if I go back to NeuVector, to Rancher, and I try to execute a shell, I can see that it's no longer possible because the shell process gets killed instantaneously once I try to spawn it. NeuVector kills it. That's because I enforced this protect mode. For example, if I now figure the web application or the data loss prevention. And I say, okay, not alert, but deny the data loss prevention part. So the request is still allowed to go in, but nothing is allowed to go out. That's actually a part I hope that works now. So we see timeout since we got no response, but we should see, just I hope that we can still see it in the logs that the request came in. Yeah. So we see that something came in, but it's not allowed to go out anymore. Next thing we're going to do is we're going to deny the web application firewall sensor as well. So this will also not work. but we won't even be able to see it in the container anymore. So nothing's showing up. So the request is even prohibited from getting to the container itself. And of course, also from leaving the cluster. What I could additionally do, I could just create a network rule from my log4j app to the internet that just denies everything. So I don't even need to have this web application firewall and data loss prevention checks in place. And that's actually quite expensive in terms of compute cost, especially if you activate these sensors on each and every application you have. Since it needs to do deep inspection on each package, you could just create a network rule, because this service is never, or probably is never supposed to call the outside world from itself. I could just create a network rule that blocks all outgoing traffic. In terms of compute resources, it's way cheaper, and I enforce security by design. I'm going to skip that now since it wouldn't change the view. But that's pretty much what NeuVector can do for you. Many things more. For example, you could also have some kind of response rules. So if you detect a security threat, you could do something with that. You can trigger webhooks. You can put the application into automatic quarantine so that no traffic gets in or out. Slack notifications as well, of course. So there are many integrations. You can do the same thing, not only for containers, but also for nodes. So you could, for example, also configure a host firewall via NeuVector, since this is just a privileged container running on each node, the enforcer we saw before. So you can also do the same things you do in a container in terms of compliance checks, etc., also on the nodes. And what's quite cool, since I talked about software supply chain security a little bit, we can also use 6-star verifiers since last version before, like last major version, I think, 5.1 or 5.2. So you can even check the signatures if you have signed images right now. That's actually quite cool. Who of you is signing artifacts? Wow. I never got a positive response on that question. Yeah, for us, the important thing is all of these incidents are reported in a security event log. We can export that. That's especially interesting for consultants like me if we work in highly regulated environments. Companies need to have reports on their incidents. That's also what NeuVector can get you. Apart from the technical stuff, you also have the reports and the transparency. Any questions so far regarding the technical side of NeuVector? Partly. They started with eBPF like a year ago or something, but they did not write this eBPF train from the start. That's actually what I meant when I said SUSE bought NeuVector as a company and they open sourced it, because there's a lot of private IP in the initial way. They did all this network scanning and this policies without eBPF. They're making more use of it now since eBPF apparently is more performant, but initially they made their own thing. That's actually quite sexy, to be honest, because you don't have to care about the application. You just have to care about this one policy that you deliver with the application, but you don't have to care about sidecars, service meshes, stuff like that. A project I currently have is integrating this stuff with a service mesh. That's where it gets funny, but it works. Sure. No. NeuVector is just an application on top. So no CNI. I think there was another question. Yes, no? When I did research for this talk, I saw that like a year or year and a half ago, there actually was some kind of initiative to promote NeuVector or to donate NeuVector to the CNCF, which would have been called Open Zero Trust. When I asked how the progress is, response was, well, no response. but at least there was some intention to actually open source, like CNCF open source this whole thing. But it's all on GitHub. It's transparent. It's like SUSE does open source. Not everything by CNCF, but at least transparent. Okay, I think we had the alerts, we had the protect mode, we had the bash, we had the WAF stuff, yeah. And everything worked, great. Okay, I already warned you before I'm going to finish. One last time, we had KCD Austria last year at the Cineplex Wienerberg in Vienna, which was really, really great. So you can see this is the main food court and sponsor court we had. We had about 300 guests. We had 35 speakers from all over the world, from South Africa to Israel. Really, really, really great event. We had tremendous feedback. As I said, 300 participants, 100 responses. Not so bad actually for return quote for post-event survey. Last year we had 3 gold sponsors, we had 10 silver sponsors and some community sponsors. If your company is willing and interested to sponsor KCD, there's still some spaces left, so please reach out to us, since Juliana is also a member of the organizing team. It's going to be on the 8th to 10th of October. This time I didn't miss the date. We presented KCD Austria at KubeCon last week, and the only thing we forgot was the date. Yeah, so would love to see you there. It's going to be a tremendous event. I'm pretty sure about that. This year we even have workshops, so we have one dedicated day for about 4 workshops. So deep dive, long technical workshops. So there's not going to be like 30-minute talks, but also real hardcore deep dive content if you're into that. Yeah. Any questions? Do you need the mic or? For runtime security, I wouldn't. For runtime security, NeuVector is really, really cool. I would probably choose another tool for some of the supply chain security things. So for example, you can scan images with NeuVector during build time, but you need to do that over the NeuVector API, send the image information there. That's kind of clunky. It's just, yeah, it's not so, usability-wise, it's not so cool. There are better tools, Trivi, Sneak, whatever, that do a better job there. But for runtime security and everything that's happening on the cluster, NeuVector is really, really hands down great. Yeah, but for software supply chain security, there's better stuff. NeuVector is free.